All right, thanks for having me. I'm delighted to be here. It's good to be in company of people who actually have a conference dedicated to e-assessment in mathematics. It's something I've dedicated the last 8 years of my life to. So every time I've ever talked about Mathspace and what we're doing at Mathspace, it's always been to an audience who's generally pretty new to e-learning. And so to actually talk in a bit more detail today to an audience that actually has some experience in the area is just, it's different for me, and it's exciting for me to actually dive in a bit deeper into some of the aspects of adaptive learning. And so I'll get to that in a second, but first a bit about our journey, and thanks Chris for the intro. Like I said, I've been at Mathspace now for 8 years. Previously, I've always been a maths geek. That's kind of where it all began for me. And back in high school, I skipped a year in mathematics and did the highest level of mathematics and went on to score a near perfect score in the university entrance exam for mathematics. Coming to university, I wanted to do something that obviously had something to do with mathematics, and I heard about actuarial studies as a science that involves really hard mathematics and statistics that's only had a 33% pass rate. And I thought, yeah, that sounds great. Let's do that. So I went on to do actuarial studies at university and the Masters of Commerce in Business, and then it was time to get a job. And when it came time to get a job, again, it was all about, okay, I want a job that has something to do with mathematics. Obviously, actuarial studies actuarial science was an area I could get into. As I was looking around for jobs, I saw a job ad that said the very first stage of the job ad to get the job is to pass an 80-question maths test inside 8 minutes. I didn't even really look at what the rest of the job was. It just sounded like, hey, that sounds pretty exciting. Let's do that test. So I ended up doing that test and getting the job, and it was a job as a derivative trader. Basically, using your mathematical brain to trade options on the stock market. It was a great job. I really enjoyed my time there. Really got to exercise the mathematical brain and the probability and the statistics that I'd learned at university. And I did really well there. So it's a highly lucrative job. I was there for 4 years. Just at the 4-year mark, I was actually named a partner at the firm. It was Sydney's largest derivative trading firm. And things were going really well, but only a month later I decided, you know what, this is not the job for me, and I called it quits. And the reason being was the year prior to that was the global financial crisis. And in the midst of the global financial crisis, volatility in the markets was obviously at an all-time high, and volatility is a derivative trader's dream. That's where we make the most money because there's large fluctuations in prices. Now, so I would be in the office trading derivatives, and pretty much every day or every second day we're making record profits, and we're in the office high-fiving each other. Wow, great day, great day. Then we'd go home and watch the news and see the world is falling apart. It's like, what is going on here? The world's falling apart, but we're loving it, and we're almost praying every day for more volatility. And so I thought, this doesn't quite sit right with me. Now, don't get me wrong, derivative traders did not cause the global financial crisis. We had nothing to do with it, but what we did is we just understood pricing better than anybody else. So we were in a position to take advantage of it. But derivative trading is a zero-sum game. You only win if somebody else is losing. And I felt to myself like, no, I want to do something where there's actually some value creation, not just zero-sum. And that's really where I decided to call it quits, not knowing what I was going to do next, but I knew it definitely had to have something to do with mathematics. And a friend of mine asked me, I was actually his boss at the time at the derivative trading firm, he said, what are you going to do next? You're going to leave this hotshot job, you just got named partner. I said, I'm going to take a year off, and then I think I'm going to become a maths teacher. By the way, I love that I can say maths and not math. I always, when talking to a US audience, I always get mixed up with that, but math in Australia as well. So he said to me, he actually started a tuition company while he was at university. And he started one-on-one tuition, driving from house to house. I know I used to do that as well. Maybe a few people in the audience used to do that, tutoring. And then he thought to himself, well, I can scale this by starting up a tutoring company, because what I'm teaching one person, I'm teaching the exact same thing to the next person. Why don't I get a group of them together? And that was kind of the seeds of the idea of, well, if using technology, you could potentially teach a whole bunch of people at the same time. And that's really where the concept for Mathspace started. So he pitched that idea. 1 month into my 1 year off, I started thinking about it, and then like 2 weeks later, it was like, okay, let's get into this. It just sounded really exciting. That's really the beginnings of Mathspace. So that happened 8 years ago now. Since then, we spent the first 2 years in really an R&D phase, and then we launched the product in Australia, starting off in Sydney, New South Wales, and then expanding to the rest of Australia, and then on to the US, and we also more recently have a presence in the UK as well. And getting started with that, and one of Michael is in the crowd today, who's our UK representative. So, okay, that's a bit about the journey of Mathspace, and I guess why I am here. And specifically, what we want to cover today is I want to give everybody a bit of a framework to think about adaptive learning. Adaptive learning has become a bit of a buzzword in education circles. A lot of products claiming to be adaptive, and what I think a lot of people would benefit from is having this understanding of what exactly adaptive is and the various layers of adaptive learning. So adaptive learning really just means that the response adapts to the student's input. But there's various layers of that, and you can be slightly adaptive. I mean, every piece of software is kind of adaptive in that sense. So hopefully today you'll get a better understanding of what adaptive learning is and a framework for thinking about it when you're talking about adaptivity, certainly between each other. I think this is starting to become a bit of a common framework to talk about the loops and layers of adaptive learning. So I'll talk about an inner loop, which is the step-by-step, the step-level feedback, the middle loop, which is the item selection, the question selection after every question, and then the outer loop, which is more the skill level, the subtopics that students are working on. Okay, and then I'll go on to a bit more practical how this works inside Mathspace with some examples from Mathspace and the various tasks that instructors can assign on Mathspace. We call them custom, adaptive, and fast-track tasks. And each of those kind of targets the different levels of the different layers of the adaptive learning. I'll also quickly talk about handwriting recognition as a kind of a feature inside digital software that's becoming quite important to lower the barrier of entry to students actually using digital assessment. And finally, we'll do something a bit interesting, and we'll take a deep dive into the infamous Hannah's Sweets exam question, which you might be familiar with. It's a UK GCSE exam question that a couple of years ago was in the headlines, so I think we'll take a deep dive into that. I can see some people smiling and nodding, familiar with that question. All right, and I'll use that as a kind of framework to maybe rethink assessment. What do we really want to achieve out of assessment? Okay, so to begin, so the layers of adaptive learning. Inner loop is that step-level feedback that we give students as they're going through. And this is really where the intelligent tutoring systems come in. It's probably the hardest to develop because it is super context sensitive. It's taking that student response and giving a very direct answer. And that's kind of probably the most complex part of the layers of adaptive learning. And the middle loop, as I talked, is the item selection. After a student responds to a question, what question do we give them next? And the outer loop, again, is where the subtopics and skills, what content should they work on in the first place? Okay, so focusing on the inner loop. Okay, so probably the most difficult part with this is ideally you want to try and accommodate for the different student pathways. And it's probably best demonstrated by an example. Now, I'm going to try and hold on to my screen so it doesn't fall off the edge. I need to buy a thinner laptop. It's a bit older laptop, so you can make them thick. Let's have a look. Okay, starting with an example of three-step equations. Here we go. And I will log in. Okay, so I'm obviously using specific examples from Mathspace here because that's what I know, but this, obviously the layers of adaptive learning could apply to any mathematical software. Make this a touch bigger. Okay, so looking at solving this three-step equation, solve minus 4x on 5 plus 1 is equal to minus 23. I'm going to go with the first step here of minus 4x on 5 is equal to minus 24, and then I'm going to submit that. And you can see here we've marked that step as they're going along. So this is the step level in a loop. As a student is working through a problem, we're giving them feedback as they're going through. If they were to get that answer incorrect, then they'd get that feedback that that's incorrect step. Okay, so this is the inner loop. More than that, we have that context sensitivity. So if a student doesn't know what they're doing now, they can ask for a hint. When they ask for a hint, take them back to their last correct step, the minus 4x on 5 equals negative 24, and it'll tell them what operation can we apply to both sides to remove the fraction. So the hint that's being given there is not a generic hint that's for every student. It's context sensitive. It's given the last correct step that they were on. And this is really where that inner loop comes in. If a student still doesn't know what to do, we can provide a second hint. And in that second hint, we're more explicit, multiply both sides of the equation by 5. And you can see we can also provide some scaffolding on how to get to that next step. And this is something that we've actually added later. We initially didn't provide any scaffolding, but we found that for a lot of students, the problem is not always the mathematics, it's often the reading. And so adding that bit of scaffolding really gives a lot of extra context to the hint. So multiply both sides of the equation by 5 with the scaffolding and fill in the box kind of questions. Hopefully all students can get some success at that level. But if they still can't, they can skip a step and they're actually shown that very next step. And this is important because for students, certainly in the learning mode, and Mathspace was really designed for a high school audience. It's being used at tertiary level, but really the initial design was very much for high school and very much for a learning experience rather than assessment. So while a lot of teachers are now using it for assessment, instructors are using it for assessment, and I'll get into some of the modes that teachers can assign tasks in, certainly our primary reason for existence and our primary aim and vision was to create a learning experience with Mathspace. Okay, so they can skip that step, and I guess the important thing about skipping that step is that we don't necessarily say it's an all or nothing approach. If you don't know how to do the very first step, but you can pick up from there and move on, then that's great. And I guess that makes a lot of sense in assessment as well, where you want to give students partial marks for getting part of the answer correct. Okay, now I want to show what happens if a student was to take another path. So we went down probably the obvious path of subtracting 1 from both sides, but if a student decided to first multiply everything by 5, 115, I think. So test my maths. There we go. Then you can see that it's smart enough to pick up that's correct as well. Okay, so they don't have to go down the obvious path, the particular path. And that's really where some of the intelligence comes into that inner loop. It's in equivalence marking, that whatever path a student goes down, is the system able to pick up the correctness of that answer. Anybody who's, I guess, worked with, so if you have used software that does this kind of step-by-step marking and can give responses whether a student goes down a particular path or another path, this is what I call the inner loop adaptive feedback, and it's the kind of intelligent tutor system. It's probably the most difficult part to actually build in software. Okay, now if a student was to now get stuck and not know what to do next, then they can ask for a hint. You'll see that the hint now is very specific to that step. What operation is needed to isolate the x? We must reverse the operation of adding 5. And that's the context sensitivity of, depending on the student's path, we provide a hint for that student to go through. Now, I will say that this isn't always the case. What we try and do is to cover as all the paths that we think a student might take. But it's not smart enough that if a student was to, write an integral that has the same answer now, that it would be able to pick that up. It'll actually take them back to the last reasonable step that they entered and give them a hint from there. And we've debated whether we should actually invest the time to try and make the system even smarter, that if a student was to do something strange like, let's say they were going to do something strange like, for some reason they wanted to add 1 to both sides. All right. Don't know why they would. the system is smart enough to know, yeah, that's correct. And we've debated whether we should give them a specific hint for that case or not. And we actually felt that it's probably worse to do that. It's probably better to say, no, go back to a reasonable step and work from there, rather than let's continue from this unreasonable step that you've taken. Okay, so that's really the inner loop, and I want to show you one other example of that. If I can get back to here. There we go. This is a geometry example. And I don't know if it's happening in the UK, but or other parts of the world, but geometry seems to be getting removed from more and more from higher ed curricula, which I think is a real shame. I'm personally a fan of geometry and geometric reasoning. I think it's a great way to teach logic. But in any case, it's a really good example of showing that step-by-step level inner loop intelligent feedback. So here we're looking at a question. We need to find x, given those 3 parallel lines. Now, I want you to imagine what the very basic mathematics software where it's a multiple choice question. If this was a multiple choice question, or just an x equals box. A student would look at this question and they'd be like, okay, I need to find x. X, I've got one angle, 123. So x can maybe be 123, or I know there's something special about 180, and so x could potentially be 57, so it adds to 180. And given that it looks acute, it looks closer to 57, I'm just going to go with that, x equals 57. And the student does that, and they say, correct, you understand geometry. When in actual fact, they have no idea about the geometry that's going on behind this diagram. So even in Mathspace, if the student was to say x equals 57, we say, you need to show another step before this step. Okay, so sure, you've got the right answer, but that's not good enough. We're looking for the reasoning behind how you got there, the x equals 57. And so they need to actually find another angle first. Okay, now I'm going to leave it to you to tell me which angle would you like to find, because there's obviously multiple ways that you can prove that x equals 57. So any takers? BGD. All right, let's go with BGD. Angle BGD is equal to 123. Okay, and we don't enforce the degree sign. You can put it in or not put it in, which is, I know, mathematically we really want them to put it in, but from a student perspective, it's super frustrating to have to click degrees every single time you want to do that, so we're trying to find the right balance there. Okay, so we've done that, that's correct. Now it's time to give a reason. And what we do is we basically have a keyword search through the list of reasons. So from a keyword search, we know it has something to do with parallel lines. So we can start typing parallel, and then all the reasons with parallel come up. And we can choose basically from there corresponding angles in parallel lines are equal. Okay, and I know this is different things in different parts of the world they call it, but I'm pretty sure in the UK it's similar to Australia. You call them corresponding angles in parallel lines. So hopefully no one's surprised by the terminology there. Okay, so angle BGD is 123, great. Now that we've found that, we can now find x. And so now when we say x equals 57, it says correct, and what's your reason? So notice that over here, we have found this angle there, angle BGD. So obviously the reason to getting x is that angles on a straight line are supplementary, add up to 180. Now, had we found another angle first, so had we found instead, we went with the green angle over here, and then we'd need the reason of vertically opposite angles. So it's sensitive to the path that the student's taken. So if I'm going to try vertically opposite angles now as a reason, which could be a reason for x being 57, but we haven't shown that. And so when I enter vertically opposite angles are equal, it tells me that's incorrect. That's not the correct reason in this case because I have found BGD, and so the reasoning I have to use is that angles on a straight line, angles forming a straight line are supplementary. And that is correct. So this is a really good example of that inner loop in action there. It depends on the path that a student takes, where the response, the correctness of the response depends on the path they took. So if, like I said, if a student was to first find angle, if they were first to find this angle here, they'd need to use co-interior angles as their rule, and then they need to find vertically opposite angles to find that. If they were to find this angle first over here, then they'd say first that's because of alternate angles, and then they could find x by co-interior angles. All those cases are covered. Okay. All right, so that's the inner loop. The middle loop is what happens after a problem. So students get served one problem at a time. Once they get that question correct or incorrect, it's what question do we serve them next. So generally what we try and do here is as the problems, as students get them correct, we want to progress them to more difficult problems. As they get them incorrect, we want to take them back to simpler questions. Now all the questions that digital assessment can serve up or randomise. Generally, all good software would randomise the numbers that are there. So you can actually forever generate more and more questions of the same type to get students familiar with the easy concepts before progressing them to the harder ones. We at Mathspace use item response theory. A lot of literature about it as a way to determine what the most suitable next question is based on the student's mastery. So feel free to read up on item response theory to get a sense of how that all works. At this stage at Mathspace, we only take difficulty of the question into account, and we use two factors to determine difficulty. One is our in-house math instructors, maths instructors, who basically they will actually sort the questions in terms of difficulty, so their personal rating on the difficulty of the questions. And the other is actually all the users that are using Mathspace. So we now have hundreds of thousands of users using Mathspace, so we get a lot of data points of which questions are most difficult. And we use a combination of those two because we found that we always want to keep instructor, we don't want to go fully data-driven in that sense and lose the value of instructors actually knowing what sequencing that question should take place. Okay, so we'll take a look at an example of this in action as well. Okay, so I've chosen a subtopic here on expanding binomial expressions. Okay, and this is the very first question in the set. And you can see it's really trying to lead students into the concepts of expanding y plus 8 multiplied by y plus 9. The very first part is what is the area of the rectangle A. So you can see you have the y plus 8 and the y plus 9 over here. And we need to find the area of that rectangle first up. Okay, so I'm going to start with the student to, hopefully everybody knows how to do this basic multiplication. Okay, the area of rectangle B, 8y, area of rectangle C, 9y, area of rectangle D, be 72. Okay, and then use the areas of each to find the area of the whole rectangle. So we have y squared, plus 8y plus 9y plus 72. And of course I can show the working out, and we hope that students do show their working out every step of the way. And then 8 plus 9, 17y. Okay, cool. So we've got that question right. And you'll notice over here, I have achieved some mastery for getting this question correct. And I just want to show kind of the progression of the questions as we do this. So now that I've got that question correct, I move on to a slightly more difficult question. with some scaffolding on how to do an expansion. So I'll also get this one correct. 9 outside of t plus 2. Okay, I got some more mastery and the questions. So every time after the question is done, algorithms churning using item response theory to work out what is the next most appropriate question for this student to work on. Some still scaffolding, but a bit less than before. Now they have to put in the whole second side expression. Again, I will get this correct, I hope. Okay, and I'll get one more correct and then I'll start making some errors. So now it's, all right, you're on your own. We've got you some scaffolding. We can see that you've done that. You've achieved some mastery. Now you're on your own. Start working on binomial expansions. So we'll go with x squared minus 15y. And I should show my working, but I can do this all in my head. Plus 36. Oh. This is what happens when you introduce a variable that's not part of the expression. You introduce a variable y which is not needed. Don't sweat it, you haven't been marked wrong, because a lot of students get super frustrated, so we have to remind them that, hey, it's okay, you haven't lost any marks for this. Okay. That's the inner loop at work there. Okay, back to the middle loop. The next question. Okay, so now we're really testing that the other way around. Do you know what that missing expression is? I'm going to get this one wrong. And the best way to get it wrong is to ask for hints, ask for another hint, still don't know what to do, ask for a next step. Okay, show me the answer. Now I got that incorrect. I didn't get any mastery because I got that incorrect. Hopefully I've learned something through reading these hints and I didn't just click hint next step blindly like I did just there. And then I move on and now it's back to the simpler questions as I go through. And again, if I get these incorrect, hopefully with all this scaffolding, they're actually starting to, they won't get the whole thing incorrect, but the questions will start to get simpler. And now you can see it's kind of taking them back to a multiple choice question, getting them thinking again about expansions. So that's that middle loop in action. That's the item selection after every question, progressively getting harder. So this achieves two things really for the students who are a bit slower and need more help. They can focus on doing more practice of those easier questions with different numbers and really consolidating their understanding. They can stick around those questions that have the scaffolding before they move on to working on the questions where we can remove the scaffolding slowly as they move on. For the students who know what they're doing, there's nothing worse than getting them to spend, work out 10 questions on, the really simple stuff when they already know it. We can really speed them up to questions they already know, to questions through the stuff they already know so they can start working on that in that sweet spot. There's some research done about this. They call this the zone of proximal development, which is where kind of the sweet spot where we want people to be. It's that area where they're not bored because they're working on things they already know, and it's not where they feel too challenged because everything is just outside their ability. And that's really what we're trying to do with that middle loop is once we've honed in on the correct subtopic area that we want a student to work on, can we get them working for as long as possible in that zone of proximal development? And the interesting thing is the way these loops work, they work together. So I think the best e-learning solutions are ones where the inner loop, the middle loop, and the outer loop all work together, and they're not working in isolation. So as an example of this, you can see the middle loop in action here of taking them to another question. Let's say that it's taken them to a question that's too difficult, but when that question is too difficult, the inner loop starts to help them with the step-by-step feedback. So hopefully that inner loop, they're actually learning something from that. When they get taken back to a similar question or a slightly simpler question, they've learned something and they can move on. So you can see the inner loop and middle loop are really kind of intertwined there. And I think that's really, in terms of what we want to achieve at Mathspace and what we think the future of e-learning is, it's in getting those loops communicating well with each other. And there's so much more we could do there. We're only kind of just scratching the surface. Okay, so that's the middle loop. Let's check how I'm going for time. Go. Okay, I think we're running well. I think on track. We'll move with the outer loop now. So the outer loop is really focusing on, should they be learning this content in the first place? Are they even ready to learn binomial expansions? If they don't know how to multiply x by x, then they're certainly not ready to expand binomial expressions. So again, two things that are achieved there. We want to quickly identify gaps in their knowledge to say, well, you're not ready to learn this. There's other content you need to learn first. And the other extreme is the student who does already know it. We want to fast track them and say, well, there's no need for you to spend a lot of time working on binomial expansions, for example, when you're ready to learn calculus. So those are kind of two things that we want to achieve. And I'll show you how that kind of looks like inside Mathspace. We'll take a look at the knowledge graph for fractions inside Mathspace. Okay, so I'll make this smaller first so that you can't see anything. This here is our knowledge graph for fractions inside Mathspace. Each one of those little things there, let's make it bigger, is a subtopic. A subtopic inside Mathspace is basically what you just saw with expand binomial expressions. That's what we call a subtopic inside Mathspace. Generally, it's a set of 20 or so questions, questions, each one with a kind of slightly different skill that it's assessing. So you saw it with binomial expressions. The very first question was one that had the rectangles, the area of rectangles, and then we had some scaffolding, some where they had to do it backwards, some where the numbers got higher, some with negatives, etc. as you go through. So each one of these is that kind of maybe 20 questions that it's addressing. And so here it is for fractions. You can see that, for example, we have order and count with fractions. Now, after you've learned order and count with fractions, you can go to identify the value of fractions from area models, or name, identify, and compare mixed numbers. Compare and comment on the size of fractions by relating to benchmarks. Add fractions, relate to size of fractions. So you can see it's an order that we have here of how the skills should progress. And this is, again, similar to what we had with the inner loop. The outer loop is done, two things inform that. One, our in-house mathematical teachers, our experts, our content subject matter experts, who actually put these things in the correct order based on what normal mathematical development is. And two, using the data that we get from students. Do students who master identify the value of fractions from area models, do they normally go on to do well in compare the size of fractions using models? Okay, so those two things together. We don't actually use an algorithm to do any of this automatically. This is all, we feed that data back to the subject matter experts, and then they manually adjust this, the arrows basically, the direction of stuff based on the data that we're feeding back to them. So there are times where we get data that suggests that one thing should be before the other, but it doesn't make sense from a mathematics teaching perspective, and so we always leave the final say to our content, our subject matter experts. Okay, so that's what it looks like for fractions. Okay, and you can start to get a sense of just how much mathematical content there is if this is just fractions. Actually, I've got a little visualization I might share with you to give you a sense of that. Okay. This is the same graph with early fractions. Okay, so again, each node might have 20 questions, all with random numbers, and this is the kind of the shape of how students might progress through those skill sets. So this over here, for example, is order fractions by approximating their size to benchmarks. Okay, this is how it looks like when I add, let's do early fractions and fractions. Okay, so added some more fractions. Just to give you a sense of just how much mathematical content there is, let's throw in some early decimals. Okay, let's look at the entire curriculum for, I won't look at all of it because it might explode. I'll look at like half of it. Okay. Right. It's not very helpful as visualization, it's too big now, but it just gives you a sense of the amount of mathematical content. And really, this is what a lot of good educators say. This is kind of what I think when I'm sitting next to somebody trying to teach them mathematics. It's that one-on-one tutor. In my mind, I'm sitting there going, well, you can't do this question because there's actually all these subtopic areas that you don't know. And I try and identify where their gaps are and go back. And this is something that a computer can potentially do a lot better. And really, this is the grand vision for what we want to achieve at Mathspace, and I think what digital learning in mathematics can look like. That every student has highly personalised instruction, getting the right question for them in the right topic area, right in that zone of proximal development. There's still a lot of work to do to get there, but these, I think, are the framework for achieving this is thinking about that inner loop, that middle loop, and that outer loop, and then how those loops interact with each other. And this is really what we mean by that outer loop. Can we identify among all this mathematical landscape which node we should try and hone in on, and then we can use the middle loop in there to get the right questions within that node, and then of course the inner loop with the step-by-step feedback, so that hopefully every student is engaged at exactly the right zone of proximal development. Okay. So that's it for fractions. All right, applying the layers of adaptive learning in Mathspace. I've already kind of shown a bit of this, but I'll just talk briefly about some of the tasks and how we'd like teachers to think about adaptive learning inside Mathspace. I'm back. Okay, so we have 3 types of tasks inside Mathspace that's kind of focuses on the various layers. The custom tasks, we allow teachers instructors to completely customize the tasks. And I'll show that in an example in a second. Adaptive tasks are really the one that focuses on that middle loop, on teachers, instructors don't need to hand-pick which questions to assign students, they just pick the node. We're all working on binomial expansions. Everybody work on that. Mathspace do the rest. You choose the questions adaptively based on how the students are going. And then there's the fast track task, which is a topic level diagnostic. We focus only on a topic level because we can't yet focus on the entire curriculum because you saw how big it is. The test would take too long, no one would actually do it. So we allow teachers to choose a topic level. So they might choose fractions or algebra or equations, a bit more specific, and we will choose questions from different parts of the nodes to try and hone in on what parts of the whole graph that students know and don't know, and then they can focus further on the individual nodes themselves. Okay, so, and each kind of achieves a purpose. I just want to talk a bit more about adaptive tasks. So with adaptive tasks, they can be student or instructor driven. So we don't need an instructor to assign those tasks. For custom tasks, they need to be instructor assigned. And what that means, I guess, what we're trying to do with it is really encourage a growth mindset. And we do that by reporting on mastery rather than a score. So when you have a set of 10 questions and everybody needs to do that same set of 10 questions, then at the end of it, you report a score of how much you scored out of 10. And the student who scored 2 out of 10, they see that they scored 20%, and that makes them feel really bad. Whereas with an adaptive task, what we report on is that mastery. You recall seeing that green bar that grew as student got those questions correct. How long it takes to fill that bar varies depending on the student's ability. So that same student who got 2 questions right out of 10, they would get more easy questions that stick around that zone of proximal development, but they won't report seeing 20% as, and you failed, you scored 2 out of 10. They'll see that as 20% mastery towards my goal of 100% mastery in this subtopic. And the only thing stopping them from getting to 100% mastery is to do more questions. So for the A student, it might be just 10 questions and you get to 100 mastery because they're getting everything correct. But for that weaker student, it could be that they need to do 30 questions. They need to practice a lot more on the easier questions, which slowly remove that scaffolding as they progress. And the amazing thing about this, more than anything, is that growth mindset that it puts in the students. Instead of reporting to students, and we've probably all heard of mathematics anxiety, and students who are just anxious about mathematics, they've had a bad experience and they kind of feel, I'm not a mathematics person. I feel that adaptive tasking is a way to actually start to tell students that mathematics is, you're not a mathematical person or not a mathematical person. Mathematics is an endeavour where you need to actually struggle and persist, and that's where you actually learn and grow as a mathematician. And to focus our assessments around that, and more so, we're pushing teachers, encouraging teachers to stop assigning the traditional custom task, which is just the formal assessment of these are the 10 questions and you'll receive a mark out of 10 at the end of the day, to saying, well, I don't really care. I just care that at the end of the semester that you've actually mastered everything you need to in algebra. And you can, I don't care if that took you 10 questions and 10 minutes to finish, or it took you 40 questions and 2 hours to finish. It doesn't really matter if you've mastered that content. And hopefully we can build that right mindset in students. And it really comes down to how instructors in the class deliver that message. One thing we found with anxiety is a lot of students, so Mathspace is effectively now being used as a textbook replacement in a lot of high schools. Instead of going through, because of the vastness of the content, instead of going through and practicing questions inside on pen and paper and getting no feedback, we have the vastness of complete curriculum coverage, so you can do all of that in a digital format with all marks and all results stored for the teacher to review and the student. Now that also causes a bit of anxiety for students. So you'd think, no brainer, of course, why wouldn't I actually do the exact same thing I've been doing on pen and paper, except now I have a record of all of that. But for students, we found that for a lot of them, the fact that their teacher can now see every last bit of work that they've done in mathematics is a bit of a problem. And the way we've really tried to address that is it all comes down to how it's sold to the student. Is it that a big brother kind of, I can see everything that you're doing in mathematics? Or is it, and this adaptive learning of mathematics is a journey, and we want to kind of record your progress throughout that journey. And we found those who focus on adaptive tasks and sell that message of growth mindset, and I don't really care what you score on the exam, I care about how you progress through the learning, and if it takes you longer, it takes you longer. They have a lot more success in getting their students on board with moving towards digital, rather than the big brother, now we're going digital, I can see everything that you've done. Okay. All right, and then the last one, of course, is the fast tracks, where we have the topic selection. All right, I'll quickly show what these kind of look like inside Mathspace. I'll create a custom task. Okay, so from your planner page for your class over here, I'm going to create a custom task for the 31st. Okay, so these are the three types of tasks: the adaptive, the custom, the fast track, all kind of focusing on the different levels, the different layers of the adaptive learning. I choose who I want to assign it to. I can be specific and assign it to particular people. I was looking for myself there, but sure, I'll assign it to Muhammad Al-Aswad. That's not me. He'll receive some homework. Then I choose my curriculum. Actually, before I get into that, this is where kind of it gets interesting. The question variation, we allow the teacher to choose if they want the numbers to vary for each student, meaning two students sitting right next to each other, one might get solved 3x equals 12, students sitting right next to them might get solved 5x equals 15. So the same question type, but the numbers vary. Or if they want students to collaborate, perhaps they want the question to be exactly the same. And then this is really where our assessment mode comes in. So you saw that with the inner loop, we provide the hints and videos as students working through. Given that we're talking about assessment here, I think a lot of people might want to turn that off. So we can choose not to show the hints and videos if you don't want to. From there, it's just a case of picking I'm going to go World of Maths, which is all our curriculum. choosing your topic from there, or we have a subtopic search, so we can say calculus. And something very college level. Here we go. Find the exact area bounded by the shared regions. And we basically from here, because this is a custom task, we can pick and choose our questions and just do a drag and drop as we go through. Notice that the numbers change, so you can actually, so y equals 2 cos x, I can drag this in again if I wanted to and have different numbers every time. Right? And it's just a case now of dragging all the questions that I like. I can choose from multiple topic areas, so I can say, well, I also want to ask some questions about solids of revolution. And so my right-hand side has the 4 questions that I've already selected. My left-hand side changes to solids of revolutions, and I can drag in some questions in from there. So basically, you can use the entire question bank of Mathspace to completely create a custom task of whatever questions that you want to have. And each one of those questions will have the step-by-step inner loop feedback that you go through. Okay, so that's kind of what that looks like. A nice feature that we've added as well is just saving this to shared exercises. So if you have multiple instructors and you want, obviously you've created the perfect assessment. You want to save that so that all other instructors at your university or school can use that same assignment over and over again. So that's what that custom task looks like. We've seen what an adaptive task looks like. I'll quickly show what a fast-track task looks like as well. Okay, so this is a fractions fast-track task. Because the fast-track task is that outer loop, we're trying to find the right skills. So we're looking at all of fractions now, and we're trying to find which content areas students know and don't know. And we're trying to call the fast track because we're trying to fast track them through content that they already know. So here we start with a simple division, and I'll just see, we try to actually start in the middle of the graph. If you saw that connected graph that we saw before, we start in the middle of the graph, and we're basically doing something like bisecting the graph. It's more complex than that, but we're pretty much doing something like bisecting the graph and choosing the most appropriate question at each point in that graph to work out where students, what they know and what they don't know. Always trying to balance, of course, the length of the test with getting accurate results. So we'll quickly go through one of these. I'll just, 8 of 9. I'll skip this question. Okay, so if I don't know what to do, I can say skip and move on, and then the questions will get slightly easier. We've just kind of bisected the graph and gone, okay, which of these fractions is furthest to the left of the number line? Hopefully I know how to do this one quickly. Submit, get that right. Move on to harder questions again. So we've got 28 on 20. And of course, I need to simplify. It's one of the beauties of, I still haven't completely simplified. I'm getting that feedback as I go. All right, and get those questions and move on. And so you can see, basically it's trying to assess, you can see how the skills are changing. And it's basically just going and bisecting the graph and trying to work out what you don't know as you go through. Okay, so that's kind of how we have tried to apply that inner, middle, and outer loop adaptive framework inside Mathspace. Last thing I'll show with Mathspace is the handwriting recognition. So if we're going to ask students to input step-by-step working out, we have to make it really easy for them, especially if we're trying, and what we're trying to do is in high schools is replace the textbook. So we want to remove that inefficiency of writing on paper versus entering mathematical expressions, especially as they get more complicated and you need to write integrals and things like that. Mathematically, a lot of mouse movements there. So, okay, go back to this question, but basically we can handwrite at the bottom of the screen. That's just me using my fat fingers, and You can see it recognises the handwriting, put that answer in, and of course it's broken because I've already started this assignment somewhere else. Okay, so here we go. Minus 4x over 5 is equal to negative 8. Recognises the handwriting. All right, and we move on, work our way through. So this has really lowered the barrier to entry. So anybody who has a tablet, it can be a touchscreen like my laptop over here, or an iPad, an Android tablet. It really feels just like your handwriting your work. One of the things we certainly have tried to do at Mathspace is we get a lot of information out of students entering their steps. And it's one thing we want to really encourage is enter your step-by-step solution, not just the final answer. And we found that for a lot of students using laptops, they would do a lot of their writing on pen and paper, and we wouldn't capture any of that information, and then they just put their final answer into the system. And for a number of reasons, one, we make all this visible to teachers. So we want teachers to actually see the thinking behind the process and not just the final answer. Two, we collect data at every point. So rather than one question being one data point of correct or incorrect, we often get up 10 data points from a single question where we have the steps that students entered, whether they asked for a hint, whether they asked for a next step, whether the scaffolding helped them. And we're collecting all that data to improve our adaptive learning engine. So the more we can take it off pen and paper and put it online, the more data that there is in there for us. And so we found that by adding the handwriting recognition, it's significantly reduced the barrier there that students want to actually enter their working digitally. All right, that's got nothing to do really with the layers of adaptive learning, but I thought it's worth noting. All right, 15 minutes, perfect. Now I'm going to do something fun. So I saw before there was a couple of smiles with Hannah Sweets. Just a quick raise of hands if you came across the Hannah Sweets question in the GCSE. All right, cool. So for the rest of you, you're in for a treat. Okay, so this was I think it was 2 years ago, a GCSE exam question, something like that. And it made headlines because it was really difficult, apparently. This is the question. There are n sweets in a bag. 6 of the sweets are orange. The rest of the sweets are yellow. Hannah takes, at random, a sweet from the bag. She eats the sweet. She then takes, at random, another sweet from the bag, and she eats the sweet. All sounds really good so far, right? Lots of just Hannah eating sweets. And then, whoa, the probability that Hannah eats 2 orange sweets is a third. Show that n squared minus n minus 90 equals 0. Where'd that come from? You can imagine students in the exam, and well, let's have a look at their reactions. You shall not pass. My mum works for an accountancy company, and it took 4 accountants 2 hours to answer the sweets question. And they have maths degrees. And then my personal favourite, Hannah, eat some sweets. Calculate the circumference of Jupiter using your tracing paper and a rusty spoon. Right. And I think this is the reason why it made headlines. It was suddenly a trending topic on Twitter and other social media. That people, like, what were they thinking? They've just made the questions too hard. And it's interesting, I guess for students, that's really what it sounds like. Hannah, eat some sweets. Now calculate the circumference of Jupiter. What's that got to do with the question? Now, I have recreated the question on Mathspace for us to kind of take and I think we can use this as a bit of a discussion topic, like a little fun discussion topic for rethinking what this question might look like if it wasn't on pen and paper, right? So for all the students, let's see if I can restart this. Okay. So let's put ourselves in the mindset of that student who's sitting in this high stakes exam. It's like the all important exam that determines what your future looks like, whether you end up getting that dream job or end up forever damned to the streets. Well, it's probably not that high stakes, but, and you get this question. Now, obviously, if it's on pen and paper, you're just pulling your hair out saying there's nothing I can do. But on Mathspace, if this was the way exams were set, then you're looking at this going, I have no idea, right? So I'm going to use a hint. And the hint tells you that we need to form an expression with the probability, and this is what probability is. And okay, you can have a bit of a think about it. Maybe this helps you, maybe not. For those that it does, great, you've got them on the right track. For those that doesn't, I'm going to use a second hint. Okay, so the probability that Hannah picks an orange sweet on the first go, or the 6 oranges out of n, okay, and then on the second go she picks an orange, so there'd be 5 oranges left out of a total of n minus 1. Hopefully, for those students who are at a level where they can start to understand that, they can actually start to have some success here, and they can put in the 5 over n minus 1 with the scaffolding to get that correct. For some students, it's still going to be too hard, and they're going to skip that step. And when they skip that step, Mathspace will just give them that answer as they go through. Right. And so obviously we're thinking about the various levels of students that we're targeting in this question. Right? So now it's not actually even a probability question at all. It's not even a word question at all. It's now just an algebra question. So hopefully some students will be able to pick up and say, well, I know how to do the algebra from here, and then get some marks for doing that. And we can demonstrate that while they, probably the most important part of the question, the probability side and interpreting the question, they couldn't do that part. They can certainly pick up some marks for doing the algebra correctly. So we can go through, and I'm going to assume that this student does know how to do some of the algebra. Okay, so they got that part right. Now, potentially they don't know how to do the next algebraic manipulation, and then they can ask for a hint. Okay, the hint says cross multiply to give the fractions, and maybe at this point they're like, I do know how to do that. I remember cross multiply, my teacher saying something about cross multiply, and then they can pick up and get that part correct. All right, now we think about the skill to get to the next part of this question is expanding binomial expressions. Right? We just looked at that. So let's say, hopefully they know how to do that skill. So n squared minus n. Right, and then finally it's just showing, I guess, the answer of n squared minus n minus 9 equals 0. Now, I will note, just like the geometry, if a student said, well, I need to show that n squared minus n minus 9 equals 0, let's just write that step. It would say, you need to show another step before this step. And it'll force them to go through the working out to get there. Okay. All right, the good thing is we can also ask the follow-up question, solve n squared minus n minus 9 equals 0 and find the value n, number of sweets in the bag. Again, same thing. Student might not know how to do this skill of factorization. They can ask for a hint. Hopefully hint triggers their memory. Ask for a second hint. Okay, with the scaffolding, hopefully they can think of the 2 numbers that it will take that add to give -1 and multiply to give -90. So hopefully students can start to have some success here. Minus 10 and plus 9. Okay, you can fill that up. And again, let's go with the next step. What are the 2 possible solutions? Okay, and then just to save time, I'm going to hint the next step through it. And this is interesting as well. So when they have these 2 final answers, x equals minus 9 and n equals 10, a lot of students would stop there, not actually answering the question, which says how many sweets. So it obviously has to be a positive number. So again, if they have stopped there, they can ask for a hint. A hint, only one of the solutions is possible. Ask for a second hint. It represents the number of sweets, so it must be positive. And let's say we get that answer right. Now, if we just think about, just make this a touch smaller. think about the number of skills that are addressed in this single question. And traditional exam is really about right or wrong. You either know this or you don't know how to do this. With e-assessment, with in-the-loop adaptive learning, you basically have the opportunity to say, okay, there's the very first step, we're talking about understanding probability and translating a worded problem. The next step, we're talking about algebraic manipulation through multiplying algebraic fractions. The next step, we're talking about cross-multiplying. The next step, we're talking about expanding binomial expressions. The following step is that recognition that we need to move all terms to one side and equate to 0 for a quadratic. The next step is about factorising a quadratic. The next step is about identifying that when you have a factorised quadratic, the one that equals 0, that one of the factors must multiply to give 0. And then, of course, the final steps there is just to identify the positive solution. There's, I don't know, I think 8 maybe skills that are being addressed in this single question, and our current form for assessment is to say you either know all 8 or you don't know anything at all. And perhaps the way to going forward with assessment is to actually really rethink that and say that there's an opportunity with digital assessment to actually really hone in on what students know, what don't know. And really the grand vision, I think, for what digital learning should be is to remove assessment, remove summative assessment, and really have that formative assessment going through. That we don't have these high-stakes exams because there's really no reason to have high-stakes exams. It's with that mastery-based learning approach, we can actually say this is the content that you need to know, take as much time as you need to actually learn that all. And that's really what I kind of hope and envisage that will be the future and of something that we can kind of contribute to in the e-learning space for mathematics education, really get rid of that mathematics anxiety, something that certainly at Mathspace is something that we're passionate about and want to continue to improve on. So I am just about on time. It's a good timing. Thank you.
Thank you very much. We've got time for a couple of questions. Yeah.
Okay. You have a very complicated tree and students can go along in various ways. Do you have some sort of underlying taxonomy of errors or a way of recording the errors in a way which abstracts the essence of it?
It's a good question. We don't in a way that we can show to instructors at the moment. It's one of the things that's certainly high on our list of things to do. We have a way internally where we, so one thing I didn't show was at every step students can provide feedback, so certainly that's, and that's one area that we have analytics on, which questions we're getting the most feedback on, which steps are causing the most errors for students. And we use that internally to work out better which hints we should make better. So if most students are failing on going from step 2 to step 3, then two things generally can happen there. One, we've made an error, and there's a lot of that we pick up. And two is the hints are not, we need more scaffolding there. But we haven't got it in a way where we can pass it on to the instructor. It's one of our, certainly one of the missions that we want, one of our top to-dos. Good question. I think that would make it a huge difference to instructors to get that analytics that's really highly summarised.
Great.
Many of your examples, there were alternate possibilities for how to solve. Does your system allow for those? Does it have a preferred method, or are those derived empirically from what students actually have done?
Okay, yeah, very good question. So we actually started off with a lot of it manually covering a lot of those pathways. And we covered, certainly we have a default path, which is the path that we want students to go down. And then we try to cover all of the common alternative paths. We purposely don't want to cover every possible path because it's a lot of effort, and there's actually the gain is marginal, if at all, because we don't want students to go down an odd path. We have more and more started to build in, over time we're building in a lot of automatic rules around common pathways that we don't cover. And so some of the ones that we do, for example, is simplifying fractions or rounding decimals to the correct answers. All of those are kind of automatic trigger auto hints to let the students know to get back on the right path. So, yeah, so we cover not all paths, to summarize, but some of the kind of likely paths that a student might take.
Okay, John.
Thank you. I have, as well as a trend on Handwriting, there's also a website where you can find accountants not to employ. That aside, you suggest that e-assessment can help us pick out the things people know and not make it all or nothing. But I'm going to challenge you a bit on that, because when GCSEs came in, quite a lot of years ago now, about 20 odd years ago, part of the rationale was what you just said. Instead of penalising people for lack of knowledge, reward for what they know. And as a result, GCSE level papers tended to have more broken down questions into sections, which is fine if you're only interested in separate skills. But what took away was the ability to break out a question into separate skills. And something I think we've noticed in university is a reduction of students who have to do the analysis of questions, break it down. So I'm a little bit concerned that what you're doing in a sense is reproducing what the GCSE tends to be doing. And I want to see students' ability to use strategy to break things down. Can you comment on that?
Yeah, I'm going to say I agree totally, and it's a struggle that we have in developing Mathspace, where sometimes to ease students into it, we provide that scaffolding, a bit too much scaffolding as you go through. One thing that and I agree that I think that takes away a bit of the analytical skills of just, here's a problem, we're not going to give you any help, go and solve that. At Mathspace, we actually create these investigations where we do that, where we have content areas that are specifically kind of like go away, do them offline, no feedback. And I think that's a really important part of mathematics. So I agree. I think there's a place for e-assessment to do that kind of scaffolding and reward you for the things that you know, and not an all or nothing approach. I think there's also a place for having those kind of more open-ended, work it out on your own. And I think assessment should be made up of both those things. That's my personal opinion on it. We should still have assignments, take-home assignments. We don't have the time factor on those as well. Those more open-ended things, it doesn't really matter that they can solve those things inside 5 minutes, 10 minutes, whatever the allocated time is. It's okay to spend a day thinking about pondering a problem. And I think real mathematicians, that's actually the work that they do. They spend lots of time thinking about mathematical problems. So my personal opinion is I 100% agree. I think e-assessment should probably focus on the parts that it does well, which is the scaffolded piece of feedback and auto marking and all of that. And I think there's certainly a place and important to keep offline assessment that's more open-ended. Online or offline, but probably offline makes more sense.
Does anybody have a final burning question? All hungry? Can we thank Mohammed again, please? Thank you.